All right, here we go. Section or worksheet 11.4. Now, based off your guys' questions, let's see if we can get this to focus. Autofocus. There we go. Um, so, um, let's see. Based off your guys' questions, no one had any questions on the first number 5, part A. Part B, there was 2 questions. I'm going to skip that. You guys can look at the work online to figure that one out, or maybe I'll come back to it. But let's go to the other problems. Definitely had a lot more questions. So this number 5, which I'm calling problem number 2 on the form, consider the differential equation. So we have that differential equation. And you do a slope field. And it says, the thing I want to point out, it says 9 points, so that you make sure that you do 9 points, not more than 9, not less than 9. Sometimes the points on the axes, you might miss them, or you might think that you're supposed to do one there, and there isn't one there. So just look closely. They're not trying to trick you, but they're telling you how many points to do. So I usually say, okay, well, where's the slope 0? Well, that's a little weird right here. That's going to be when cosine equals 0, when the angle equals 0, pi over 2 plus pi k. And so that's going to be when x equals 1/2 plus k. So that'd be like x equals 1/2 and 3/2 and negative 1/2. But unfortunately, we're not graphing slopes at those weird fractions. We're just doing them in nice integers. The other place that y equals 0 is when y equals 1. So all these right here at y equals 1, they're all flat slopes. So that does take care of a third of the points. And then the other ones we might just plug in and see what the pattern is. When you plug 0 in, cosine of 0 is 1, 0, 0. So it's going to be negative 1 squared is positive 1. And then at 1, 0, cosine of pi is negative 1. Times positive 1 is negative 1. So that one's going to be a negative 1 slope. At negative 1, cosine of negative pi is negative 1. And y is still 0. Negative 1 squared is positive 1. So that's negative 1. And then at negative 1, cosine of negative pi is negative 1. And this is going to be a negative 1 minus 1 is negative 2 squared is 4. So it's going to be negative 4. So that's going to be quite a bit steeper, negative. And then at 0, cosine 0 is 1. Y is negative 1. Negative 2 squared is positive 4. So that one's going to be positive 4. This would be slope of 2, so it should be even steeper than that. And then at 1, negative 1, cosine of pi is negative 1 times 4 is negative 4. So it's going to look like that. So it's kind of a weird slope field. Usually there seems to be a little more nice flow from one point to the next, but that's it. Now on the AP test, that would have been worth 2 points out of 9 points. So the whole problem is worth 9 points, right? Each free response question. That was worth 2 points. And usually it's 1 point for the 0 slopes. So that's a point for getting all the 0 slopes correct, and 1 point for getting all the non-0 points correct. So if you mess up one of those points in those groups, you lose that point. There's no half points on the AP test. All right, B says there's a horizontal line with an equation y equals c that satisfies the differential equation. Satisfies the differential equation. Now y equals c. C is a number. So this is part B. I'm just going to show the work here. That's a horizontal line, right? If y equals c, which is just a number. Now I can look at the picture and be like, look, it's right there. The answer is y equals 1. Right? That horizontal line satisfies the differential equation, meaning it's a solution to the differential equation, which means it's the function. And we've talked about this before. If you have a bunch of slopes that go directly into each other, that's some kind of asymptote. And if you start anywhere on the asymptote, then you're stuck on the asymptote, and your solution ends up looking like a straight line, even though most of the other solutions are going to be kind of curvy. So it's kind of a special case. Now, if you wanted to go up here, you'd say, oh, well, if it's a horizontal line, the slope has to be 0. So that means that dy dx has to be 0. And you would do the work I already did earlier trying to help fill this in. I said, oh, yeah, Well, that means that y minus 1 squared cosine of pi x has to be 0, which means that y has to equal 1 for that to be true. So, I mean, that's sort of the way of doing it without just looking at the picture. But you could look at the picture. Now, so that was part B. A lot of people had a question about that. So part B is kind of a weird question, and they like to throw in kind of a weird weird question. But the good news is it's worth 1 point. So if you mess it up or you get stuck on it, don't worry about it. Just, in fact, leave some space, move on, do the next part. It's worth 1 point. If you totally have to skip it, it's not going to kill your score. If you try it and you get it wrong, it's not going to hurt your score. But part A is 2 points. You guys should get all those. Just be careful. Part C is the bulk of the points. That's 6 points. And this is what I've been telling you guys. Solving the differential equation is a ton of points. And it should be something that you feel comfortable with. So we got to take this differential equation, which is an equation, with derivatives in it, and we have to solve it. To solve it, we're going to integrate to undo the derivatives, but we have to separate the variables first. If you don't separate the variables, if you don't do this first step, 0 out of 6 points. It doesn't matter what else you do because it's just weird. Whatever you're doing doesn't make any sense. This is worth a point, okay? Integrate both sides. This right here, you could do u substitution if you felt like you needed to. U equals y minus 1, du equals 1 dy. That would be du over u squared. Now, I would just think of this like this. I would say, okay, this is y minus 1 to the negative 2 dy. And yes, there's an inner function, but the derivative of the inner function is 1. So we're not going to need anything extra out in front or do anything weird because of the chain rule. We're just going to say, all right, increase it by 1, divide by the new exponent. That's it. If you did it this way, you would eventually get to the same result, right? You could do all this extra work over here if you wanted, u substitution, but you get to the same thing. Now over here, again, there is kind of a u substitution. We're going to get sine pi x for sure. The derivative sign is positive cosine, so we don't need negative in front, but there is going to be an extra pi that pops out that we don't want, so we need a 1 over pi. Again, you could do u substitution to figure out that you need a 1 over pi in front, or you could just kind of think about it in your head. Check your answer. I always check my antiderivatives. If I take the derivative of this, do I get exactly what I have? If I get anything extra, I need something extra. Now we need plus c. So this is, in this case, I think this step right here of integrating both sides is worth 1 point. It might be worth 1 for each side, 2 points. Now writing plus c is worth a point. That's an easy point. If you don't write plus c, you lose the rest of the 4 points potentially on this problem. Don't forget the plus c. Now, let's see. I would find the c value now because they gave you an initial condition, right? They gave you an initial condition. The x value is 1. The y value is 0. And so you have initial condition. I might rewrite this as negative 1 over y minus 1. Okay, now finding the c values worth another point. So we're going to plug in 0 in for the y and 1 in for x. And sine of pi is 0. So the whole thing goes to 0. C equals positive 1. So we're going to rewrite it. So that's worth a point, using the initial condition to find the c value, the constant of integration. So now we're going to rewrite it. Okay, now we got to solve for y. This is all algebra work. It's tedious. It's hard. It's hard to not make mistakes on. It's worth 1 point. So if you make one mistake, you lose it. Just try your best. With the domain, and you gotta also make sure you got to put the domain. Now, I like to flip both sides when the variable I'm trying to solve for is stuck in the denominator. It's a lot easier when it's in the numerator, so I could flip both sides, but you can't just flip. That idea of flipping both sides is for proportions only. Algebra 1, proportions. A fraction equal to a fraction. That means this whole side needs to be a fraction. So you want to combine it together with the least common denominator so you can see it as one big fraction. Okay? Please don't make your Algebra 1 teachers cry because you're just flipping all the fractions individually. Okay, so now I'm gonna flip both sides. I'm gonna go ahead and also get rid of this negative and multiply it times the other side. And then we're going to subtract or add 1 to both sides. So this is our answer. That's our solution, but we also have to give the domain. And that either people forget, which is bad because that point might be the point that also goes with this point. So even though you do all this work correctly, you lose the point because you didn't do the domain, or the domain's a separate point. You want to get those points though. So domain, there's a couple things you got to watch out for. One, you got to look at the domain of this and say, okay, are there any issues here? Are there any values of x I can't plug into sine? No, sines, domains, all reals. Are there any values of x that might cause this denominator to be 0? Because that would be a vertical asymptote, and that's a discontinuity. So domain, I think it's good to maybe just write a little comment here to make sure. So we're going to set the denominator equal to 0. It can't equal 0, but we're going to set it equal to 0 and try and solve for it. So that's going to be sine of pi x equals negative pi. And I'm just going to say equals right now, and then we'll make it an open dot. So how do you get rid of sine? A lot of times we figure out well, what would you take sine of angle to get this? And there's memorized angles. This isn't a memorized answer. But also, this is the way you would do it. You take inverse sine of both sides, right? If you take inverse sine of sine, they cancel each other out. But you get whatever you do to one side, you got to do the other. So we're going to take inverse sine, and then we're going to divide by pi. So that's the value. But the other thing you got to worry about here, I guess, too, is that sine repeats itself, right? So the sine curve repeats itself. And I mean, you could even look at this one. Usually the period is 2 pi and this is pi, but this extra pi on the inside divides the period by that. So that's what we're looking at. And we're saying, when does sine equal negative pi? So that would be about negative 3.14. Now, this is interesting because guess what? What's the amplitude of this sine curve right here that equals negative pi? It goes from negative 1 to 1. So when does this curve ever equal negative 3.14? Never. So this actually has no answers, no solutions. It's not possible. Okay? So there's no way that this sine pi x is ever going to equal negative pi to cause this to be division by 0. So it's kind of like when you get imaginary or something like that. It's different, but we just can't do it. So there's actually no issues here. The other place you always have to check is the original differential equation. This is the place that people forget, because even if things are fine here, you got to look over here. Are there any x or y values that cause this to be undefined for any reason? Are there any values of x we can't plug in a cosine? No. Are there any values of y we can't subtract 1 and square and get an answer? No. So the domain is going to be all reals, and it's going to be negative infinity to positive infinity. On your guys' test, I'm going to be looking for this evidence that you even considered it, even though it ended up not giving us something. Otherwise, I'm just going to think you forgot or you just guessed, because, I mean, all reals is, I guess, kind of a easy thing to guess, and a fair amount of our solutions do have domains that are all reals. Okay, moving on. So usually on the AP test, one out of 6 problems is going to be like this. These are old AP questions, free response questions. One of your free response questions will be solving a differential equation. So, and I feel like these are the ones that are, not as hard as some of the other free response questions. They're, so, all right, number 6 had a lot of questions, both number 6 on the back. So we're going to go ahead and do both of those. Now, over here, this says graphing calculator. So have your graphing calculators handy because it's probably going to make something on the problem easier to do. Let v be velocity in feet per second of Skydiver at time t seconds, where t is greater than 0. So no negative time, which is something I've been pushing on you guys on these time problems. After her parachute opens, her velocity satisfies the differential equation with initial condition so that's our initial velocity at time 0. So this kind of sounds like a motion problem, right? One-dimensional motion, rectilinear motion, vertical up and down with, potentially gravity, but there's also, drag. But this is what we're not going to assume that. I think we're going to have to use this. Use separation of variables to find expression for v in terms of t. So part A is saying solve the differential equation. And by the way, the point breakdown here is this is 6 points out of 9. This is 1. Probably the weird questions, 1, and this is 2. So the bulk of our points right here are for solving a differential equation. This is something you want to be very good at. It's something that I think you can get very good at. We got to separate the variables. It says by using separation of variables. Now this one is actually, okay, so there's a v here. So we've got to get that over here. Now, is there any way, can we just add 2v over here and then multiply both sides by 2t? If you did that, I'll just show you. If you added 2v, right? If you did this is wrong. And then you're like, I'm going to get rid of the dt. I'm going to multiply by dt. Okay, but you have to distribute that to everything. So now there's a dt with that. That doesn't make any sense. You're going to have to bring all of this over by division. It is possible that you could factor a -2 out and leave the -2 on the right side. It might not be a bad idea, but anyways, I'll just bring it all over. And that means there's a 1 left over, right? There's not a 0. So there's a 1 dt. I think it would probably be helpful to factor this ahead of time. And then so when you integrate both sides, we could just put the -1/2 in front, right? And then this is going to be natural log of the absolute value of v plus 16. It's essentially v to the first power. It has a plus 16. It has an inner function. There is a chain rule issue there, but the derivative of the inside is 1, so we don't need to do anything. You can do u substitution and get the same thing. Over here, we're going to get a t plus c. So point-wise, you're getting 1 point for separating the variables. If you don't, you're probably going to lose all the rest of the 6 points. You're getting 1 point for integrating each side. You're getting 1 point for putting plus c. See, don't you want to just gobble all these points up? I mean, this is quick points, free response points. Now we got to find the c value. That's going to be another point. So they gave us initial condition, so we need to use that. Natural log of -50 absolute value plus 16. Better have those absolute values. Time is 0. So c equals -1/2 natural log of 34. Right? That's another point. Now, if you had left the -2 on the right side, things would go a little different. You would eventually get the same answer, but your c value might be different because the -2 would already be over here. So now we're going to rewrite it. Absolute values are still there. Put the v back in there. Put the t there. Put your c value you just found. So now we want to solve for v. We want to get v by itself. That's going to be another point. We also want to make sure we put the domain. Also, the domain was sort of already stated. So you probably want to actually, any domain issues that are just real world restrictions, those should also be reflected in your domain. It's not just all algebraic rules and stuff. on word problems. So I'm going to multiply both sides by -2, because before you exponentiate both sides to get rid of the natural log, you get rid of anything else out there. So multiply both sides by -2. Okay, and then we're going to exponentiate both sides. That's going to cancel out the natural log there. You're going to have absolute value v plus 16. And then we can use rules of exponents to break this up, which will make it a lot nicer and probably make the domain easier, right? And then we want to get rid of the absolute value. So we do plus or minus 34 e to the -2t. You should decide if it's plus or minus. This is a single answer, not two answers. So if you go back to your initial condition, if you plug 0 in, you should get -50. So if we plug 0 in here, and e to the 0 is 1 times 34, and then you have, let's see, did I make a mistake anywhere? Let's see. No, that's looking fine, because it should equal -50. So oh, that's my mistake. That was a 16. But I caught it because I was just trying to figure out if the plus or minus is right. I caught it. Because this is supposed to be -50. So this is going to be E0 is 34. This is 16. You would the V value, V would be -50. So that's going to give you -34. So we actually want the negative this time. Want the negative. So we're almost there. We're going to do -34 e to the -2t minus 16. So that's your solution. We need to figure out the domain. Now, you could also write it like this, -34 over e to the positive 2t. That might be helpful. You might be worried about division by 0, but any positive base to a power is never going to be 0. So can't mess that up. You also need to go back to the original differential equation and ask yourself, as far as domain, so domain of this is all reals, but you also need to look over here and say, are there any values of v that would cause a problem, cause the derivative to be undefined? And that v value wouldn't be in your domain, but you would figure out the t that caused that v value. But that's good. So the domain is -infinity to +infinity. So this is your full answer. If you don't put the domain, you're losing points, okay? So this is, I think, 1 point total for all of that. I don't know if we got the 6 points right. This was 1, 2, 3, 4, 5, 6 points. Okay? Let's get all of those. You guys are going to have these on your practice tests for sure. Okay. B. A lot of people had a question on B. Let's see what B is about. B says terminal velocity is defined as the limit as t goes to infinity of velocity. Find the terminal velocity nearest foot per second. So we're not going to give 3 decimal accuracy on this. We're going to give a whole number. Now, I don't know if you guys understand terminal velocity, but it's, let's say you go skydiving and you jump out and you're going faster and faster and faster, but at some point you stop accelerating. In fact, your acceleration becomes 0. That doesn't mean you're going slow. It means you're going very fast, but your speed is not increasing anymore. And the reason is that the drag from air, which is dependent on the square of your velocity, will equal the force due to gravity. So the force of the air acting against you equals the force of gravity pulling you down towards the ground, and you hit what's called terminal velocity. And as t goes on, you're going to approach that, right? So we could find that by taking the limit. Now, we have to have the answer from part A in order to do part B, because that's v right there. So we're going to take the limit of -34 over e to the -2t minus 16. And you guys should be good at limits. We haven't talked about them for a little while, so we're going to have to review them again. But this denominator right here is going to blow up. This is going to go to 0, right? And there's going to be a -16 left. And the units are feet per second. So that's your answer, negative 16 feet per second. It should make sense because you're falling towards the ground. So you have a negative velocity because you're going downwards, but that's your terminal velocity. So, all right. And so you want to put the feet per second. You got to put the units. Part C says, now that was only worth 1 point. So you're like, what? Terminal velocity? You're so confused by this. I mean, you could ignore that and just be like, I need to take the limit and just not think about any of the real world context of this and still get the right answer. But it's only worth 1 point. So don't freak out too much. Just try it, move on, come back to it later if you're not sure. Part C says, it is safe to land when her speed is 20 feet per second. At what time t does she reach this? So you want to figure out, what does t equal when her velocity equals 20 feet per second? Well, you need to take your answer from part A and set it equal to 20 feet per second and solve it. Now, I think there was a typo. I think, no, look, speed is 20 feet per second, okay? But we know we're going down, right? So this is the tricky part here. Either if you do speed is the absolute value of velocity, right? And it's going to be equal to 20. So that's going to be when the absolute value of this, because that's always going to be positive, right? So all this is negative. So this is for sure the absolute value. And so that's what we're trying to solve. Or you could put a negative 20 here because you know that the velocity is negative. And now you got to solve this. So this is mostly algebra work. They did throw a little tricky thing about speed in there, all right? Absolute value velocity. And we just got to solve this. Now, we do have a calculator handy. So, I mean, we could write an exact answer, I think, and be fine. Or you could write a decimal. So 34 equals 4e to the 2t. I would divide by 4 on both sides. And then I would take the natural log of both sides to get rid of the e. So natural log of 17 halves. And then you get 2t, and then you divide by 2. So t equals 1/2 natural log of 17 over 2. And what are the units? You should put units on this for sure. This is time, so this is second. So that's the exact answer, which would be okay. You could also write a decimal, plug that in your calculator, and I believe the answer is 1.070 if you round or truncate to the nearest 3 decimals. So I don't know, that kind of had some fun stuff later on. All right, number 6. Let f be a function with f1 equals 4, that for all points x, y on the graph of f, the slope is given by the slope is. So this is dy dx. They're giving you, if they give you the slope, they're giving you a differential equation. They've given you an initial condition. So you should get to a point where you start seeing this, you're like, oh, I bet I'm going to solve a differential equation. If they're giving you the derivative of something, and then they want you to find the answer at some point or something like that, then you're probably going to solve the differential equation at some point. Maybe not right away. So part A says, now the point breakdown here is 1 point for part A, 2 points for part C, 5 points for part, 2 points for part B, 5 points for part C, and 1 point for part D. So that you really want to get C right. It's probably something that's more straightforward. The other smaller point ones might be something that sounds a little strange or whatever, and hopefully you can get them. But the bulk of the points is find f of x by solving the differential equation. So most of the points, and you really only need to get like a 5 out of 9 on average on all the free response questions to get a 5 on the AP test. So, or maybe, yeah. So around 5 or 6. Okay. Find the slope of the graph Oh my gosh, guys. They gave you the slope, and they want you to find the slope when x equals 1. Now, the question, this is the slope. So you're like, okay, cool. I'm going to plug 1 in for x, but what do I plug in for y? I don't know what y is. Yes, you do. When x equals 1, y equals 4. So you actually have to use the initial condition to realize that you're plugging in x1 and y equals 4. Sometimes they give you that, and you kind of have to realize later, oh, yeah, I have the y that goes with it. That's the only way you're going to do this. So this is going to be 4 over 8, which is 1/2. So that's 1 point, and I think makes sense. It only deserves 1 point. Part B, write the equation of the tangent line to the graph at x equals 1 and use it to approximate 1.2. So one, writing the equation of the tangent line. I've made you guys do this so much. So tangent line. So the way you write the tangent line is you need the slope, dy dx, which we just found on part A. You need a point, which you've been given. And so we do point slope form, y minus 4 equals 1/2 x minus 1. Now, this is good enough for the slope of the equation of tangent line. You can leave in point slope form. The one thing, though, is on this problem, we're going to use it to approximate this. So this is called a linear approximation. I think we've talked about this before. This is where if you have a curve and you know point and you know the tangent line at that point, you can say, well, what's this value right here? And you're like, well, let's use this one as an approximation for it. And usually the further you go, the worse it gets. But this is an over approximation because if it's concave down, it's over approximation. If it's concave up, it's always the tangent line is always going to be below the graph everywhere, and it's an under approximation. So all we're going to do is plug x equals 1.2 into this equation to find the y value. So it might be helpful to go ahead and rewrite it in slope-intercept form. So we're going to get minus 1/2 plus 4. So y equals 1/2 x plus 3.5 7/2. Okay, and so we're going to say, all right, well, f of 1.2 is approximately our equation at 1.2. 1/2 times 1.2 plus 7/2. Now, you do have a calculator here, but I feel like I could pull this off. This is 0.6. This is 3.5. So f of 1.2 is approximately 4.1. And this is the way I'd write it. This is an appropriate symbol to use right here. This is not a rounding truncation error. This is a straight rough answer. Okay. And so we're using the tangent line right here as an example. This is just a quick rough sketch just to illustrate the idea. We're using the tangent line to find a point further away. So like if this was x equals 1, then we're saying at x equals 1.2, what's the value in the curve? And we're like, well, let's use the tangent line from that point to give us a rough idea. So it's called tangent line approximation. A lot of times they ask you, was it an over-underestimate or overestimate? And you have to know concavity for that. So you'd have to figure out, well, what's the second derivative there? Or maybe they told you that it was concave up everywhere, concave down everywhere. This time they didn't. So that was 2 points. Probably, if I were to just guess, I know it's probably 1 point for the tangent line, which is pretty straightforward, and 1 point for the tangent line approximation, or we call it a linear approximation. Part C. Well, part C is the bulk of our points. So I'm just going to rewrite this. And we're going to try and solve the differential equation. So we got to separate the variables first. Now, you could bring the 2 over here or leave the 2 here. I usually try and leave as much stuff on the right side as possible because it's going to all end up there by the time you're done when you solve for y. But in this case, if I leave it there, there's lots of fractions. And if I bring it over here, I'm already kind of seeing what's going to happen. It's actually going to work out really nice. But a 2 over here, I feel like is less messy than a bunch of fractions over there. So the 2y ends up in the top. 3x squared plus 1 definitely needs parentheses around it. because there's multiple terms. Don't need parentheses around 2i's, just one term. You can put them if you want. This is a point, but if you don't do that correctly, 0 out of 5 points. Doesn't matter what else you do on the rest of this part of the problem. This is going to be, you could say, all right, it's 2. This is y the first squared over 2. So it's just y squared. It worked out pretty nice, actually, having the x there. This is going to be 3x cubed over 3. So it's just going to be x cubed plus 1x plus c. So probably 1 point for both antiderivatives, 1 point for putting the plus c. Now we should find the plus c by using the initial condition. That's going to be another point. So we plug 1 in everywhere. And c equals, this is going to be 16 minus 4 is 12. So that's a point. So we're up to 1, 2, 3, 4 points. And the last point is going to be solving for y and the domain and the domain and the domain. Don't forget the domain. So we're going to rewrite this. Y squared equals x cubed plus x plus 12. And to get y by itself is actually pretty easy this time. We're going to take the square root of both sides, plus or minus. I definitely need to see that in your work. And then you need to decide, well, is it the plus or the minus? If you plug positive 1 in, you should get positive 4 out. So 1 plus 1 is, let's see, 1 cubed is 1. Oh, why did I put a c there? 1 cubed is 1, plus 1 is 2, plus 12 is 14. The square root of 14 is not 4. So I think I've made a mistake somewhere. I could, because things, this is, I've done this a couple times where I go to try and figure something out, and I realize that there's a mistake somewhere. I think my mistake was I plugged a 3 in for the x here for some reason. Right? It's supposed to be 1. So this should actually be 14. So I would have lost that point, but I could potentially get the rest of the points if I did everything correct off of that error. I mean, at least on my test, I'm going to give you guys more points. So if you plug in 1, square root of 16 is 4. It needs to be positive, so we're going to go with positive. So this is your solution. Now, we need to look at domain. If you don't do the domain, you're not getting this point. You're losing this last point. So there are a couple different, there's issues here. One, we can't do square roots of negatives. So the inside needs to be greater than or equal to 0. So we're going to set it equal to 0 and solve it now. This is a cubic. Factoring is not going to work. You could try rational root theorem if it has a rational root, but you have a calculator. I haven't used my calculator yet. This is where the calculator comes in handy. So you guys know how to solve an equation on a calculator. I'm not even going to try and graph this. I'm just going to put this equation in, x to the third plus x plus 14. And I'm really just asking myself, well, how do I solve this equation? When does it equal 0? Now, I'm going to graph it to solve it. It's not that I want a beautiful picture of this. So I'm going to go to the window. I'm going to say, well, where could it happen? I don't know. Did they tell us anything anywhere about restrictions? Now, the one thing is that 1 is going to be on one side or another. So I don't know. Maybe we do negative 10 to 10 just to try it out. I might have to go back and change it. And the y values I just set negative 1 to 1 because I just want to focus on the x-axis because I'm just trying to find the x-intercepts of that. And so there's an answer. And I guess, it's a little sketchy. I hope there's no more. I think we could figure it out in a second, though. So second calc, 0. It looks like it's between negative 3 and negative 2. So I might say negative 2.5 to negative 1.5. You could use the cursor to go on either side, and then I'm going to guess at negative 2. And so x equals negative 2.271998. I'm just going to write a few extra decimals in case I need it later on. Okay. Now, are there any other roots? And by the way, rational root theorem would have been a waste of time because that's a very irrational answer. Right now, when I do my domain, I'm going to say, okay, there's an open dot at negative 2.271 or negative 2.272 if you want to round. And then x equals 1 is definitely to the right of that. Because remember, the domain of the solution of the differential equation is a single one open interval. So right now, I'm thinking this is my domain right here. But there's some other things I got to check out too. And I'm a little wary of this because a cubic could have up to 3 zeros. But some of them might turn out imaginary. You might get multiple roots at the same location. So you don't have to have 3 distinct real zeros, but you could have up to 3 zeros. The other thing you got to worry about domain is you got to check the original differential equation. You got to say, well, is there anything that causes problems here? And you better check this. It's not just about the domain of what you have here. Now, let's see. Right here, this would cause division by 0. So 2y cannot equal 0. Now, don't put y equals 0 on your number line as another open dot because this is a domain. This is x values. But what you need to think about is like, well, when does y equal 0? What's the x value that makes y equal to 0? And guess what? That's exactly what we just found. You would use your answer and set it equals 0 and solve for x. But that's what we just did. We just figured out when it equals 0. So we're not going to get any extra points from that. And I guess I'm just going to be a risk taker here and feel like there's no other zeros to the right of this. We could make our window bigger. I mean, this isn't a fail-proof way. We could say go all the way to 100. And so there's the first one. And then, we don't see it. Now, this is also a cubic. I mean, we could try and analyze it otherwise. But our domain, we're going to write this in our answer, is negative 2.271 to positive infinity. That goes with your answer. That's like saying, here's my answer, here's my solution to the differential equation. This is where you're allowed to use it. You're only allowed to use it on a single open interval, broken up at any discontinuities like domain usually is, broken up at any indifferentiable points, which domain usually isn't. And it's only the one that contains the initial condition, which kind of makes it easier because then you don't really have to do a bunch of like solving inequality stuff like normal. So part D says use your solution from part C to find f of 1.2. So they're saying, all right, plug 1.2 into your answer. So I would just write it, show your work, and then we have a calculator. So I'm just going to put in my calculator 1.2 to the third power plus 1.2 plus 14 raised to the 0.5, and we get 4.114. Just 3 decimal accuracy for your final answers. Round or truncated comes out the same. This either way, this was worth 1 point because it was pretty quick. You're just using it. Now, the interesting thing here is this was our approximation from the tangent line, and this is the actual value, and they're pretty close to each other. So, all right, that's it. I'm not going to do the first problem. You can look at the solutions online, the work online to do that. Okay, this is a bunch of good stuff, though.